Assalamu alaikum wa rahmatullah. So in this video, let me discuss some general classical mechanics problems, okay, which are purely based on what I can say the Newton's laws. So the problem number first that I will be starting with here. Let's suppose that I have some tilted plane here, okay. For me, if this is a tilted plane, and sometimes we call it inclined plane as well, and there are no issues, okay. But for me, if this is a point angle of inclination here that I represented by theta, okay. Now जो हम इस surface की बात करते हैं यहाँ पे, the surface we are just talking about here, it's rough in nature, okay. Moment it's rough in nature, so I will expect there must be some, what I can say, the coefficient of friction, okay. So I'm assuming that there is some block here that rests on this rough horizontal surface, okay. So जो ये block rest कर रहा है इस पे, मान लीजिए इस block का mass m1 है, okay. Now there is one more block that's I can say here, and there is a pulley here, and there is a string that passed over this pulley. As a result, I have the two blocks, they are connected by means of this pulley, okay. So तो मेरे पास क्या है, एक tilted plane है, तो इस surface की बात हम जब करते हैं, it's rough in nature. जब ये surface rough होगी, obviously जो ये block इस पे lie करेगा, okay, means that when this block, I assume that it has a mass m1, it is going to rest on this surface. I'm just specifically talking about this inclined surface here. It's rough in nature. अगर ये rough होगी ना, तो इसका मतलब क्या है, यहां पे मैं एक्सपेक्ट करूंगा there must be some coefficient of friction, okay. So यहां पे एक string है that passes over this pulley, but the string at the same time connected two blocks, okay. For me, this block it has a mass m1 and this block it has a mass m2, okay. अब मेरे पास दो blocks है, एक lie करता है इस rough surface पे, and another block that lies within this region, okay. If I will expect that there is a gravity, and gravity always points in a vertical downward direction, okay. This is something that you know. Now what's my point of interest here? Basically I want to know some unknowns here. What are the unknowns here basically? So I will expect at the first place here the very important thing that this is a connected motion problem, okay. Whatever the acceleration of this block will have, with same acceleration this block will move as well, okay. Because it's a massless string, the tension will develop in the string, it will be same every point on the string, okay. So as a result, I have the tension here. Let us assume that the tension in the string that will be T, okay. अगर इस string में tension T develop हो रहा है, it will be everywhere at every point on the string. On the string it will be same, okay. तो जो हम टेंशन की बात करते हैं, अकॉर्डिंग टू न्यूटन्स थर्ड लॉ, इट विल बी ऑलवेज अवे फ्रॉम द बॉडी, ओके. तो टेंशन यहां पे है T, इट विल बी हियर T, बट अगर मुझे डायरेक्शन डिपिक्ट करनी होगी इस टेंशन की, इट इज ऑलवेज बीइंग अवे फ्रॉम द बॉडी. अब यहां पे क्वेश्चन अराइज हो रहा है, व्हाई इट इज बीइंग ऑलवेज अवे फ्रॉम द बॉडी. द रीजन फर्स्ट इज लाइक इन द सिंपलेस्ट टर्म्स, I want to explain it. Suppose this is my string here, okay. Now I am going to pull this block by means of the string, and when moment I am just pulling it, okay, the tension that will act on it, okay. If I use my common sense here, then and only the tension will act on it. If I will just pull it this way, okay. If I will just make something here, I will just do one thing, I will just apply the force, and this will just bend, this string will bend, and as a result what I will expect, there will be no tension, okay. In a common sense language, if I will just think on it, I'm just getting the kind of sense that this tension, it will be always away from it, okay. But there are other reasons too. I don't want to make such type of discussion is here. I'm just presuming simply here that whenever we talk about the tension, it's always away from the body. तो यहाँ पे इसका harder reason क्या है? एक simple सा reason ये है. तो न्यूटन्स थर्ड लॉ की जब हम बात करते थे, basically when we talk about the न्यूटन्स थर्ड लॉ, तो forces आते हैं, forces exist कर रहे हैं pairs में, okay. तो जी यहां पे इसको फोर्स, यहां पे इसका फोर्स क्या है बेसिकली, दैट इज अ वेट ऑफ दिस बॉडी, दैट इज सिंपली इफ ग्रेविटी पॉइंट्स डाउनवर्ड्स, एंड ऑब्वियसली बाय द सेम लॉजिक my weight of this block that also points downwards, okay. And as a result, what will happen here, there must be some counter force, okay. according to Newton's third law. What that force is here, basically, that's a tension it will develop in the string. I hope that you must have got it, why the tension is always away from the body. The sophisticating reasoning about this fact is basically the Newton's third law. Okay, all right. So अगर मुझे यहाँ पे अननोन्स पता करने होंगे, बेसिकली अगर मैं यहाँ पे देखूंगा अननोन्स कितने होंगे मेरे पास. लुक, जो ये ब्लॉक ये लाई करता है इस रफ इंक्लाइंड सरफेस पे, तो ये सरफेस इस ब्लॉक पे इंपोर्ट करेगा फोर्स. वो फोर्स क्या होगा? दैट्स व्हाट वी कॉल एज नॉर्मल फोर्स. ओके, at the same time, by the same logic, the weight of this block ये कहाँ lie करेगा? It will just lie vertically downwards. Okay, m1g. This block has a mass m1. It is going to be set in a gravitational field. Okay, I don't want to ignore here the gravity effect because we are living in a gravitational atmosphere. Okay, so by the same logic, the weight of the this block will be downwards. Okay, it doesn't matter in which way around my block is going to be oriented in a region of gravity and all that. Okay, तो अगर मुझे यहाँ पे एक चीज करना होगा, this is a weight, and weight, you know, it's a kind of force, and force is a vector quantity. Okay, now by the simple reasons I can just decompose the weight of body into the components, है ना. तो जो हम वेक्टर्स की बात करते हैं, वी कैन डिकम्पोज द वेक्टर्स इनटू द कंपोनेंट्स. अगर मेरे पास कोई वेक्टर होगा, आई कैन डिकम्पोज द वेक्टर इनटू इट्स कंपोनेंट्स. दिस इज व्हाट वी कॉल एज द रेजोल्यूशन ऑफ वेक्टर्स. ओके, तो यहां पे बॉडी का वेट है m1g. आई विल एक्सपेक्ट दैट इट्स वन कंपोनेंट विल बी हियर. ओके, दैट आई assume that it's l1g cos of theta. Okay, now if this is a resultant vector, its one component will be along this way and its one component will be along this way. But I can just shift the vectors, but provided that the direction of vector it should not change. Okay, तो यहां पे क्या होगा? There will be mg sin of theta. Okay, mg sin of m1g sin of theta component is weight का it will be along this direction. Okay, if this is theta here, this must be theta as well. Okay, now I am able to decompose the weight of the body into its components. One component will be along this way and one component will be along this way. Okay, तो अगर मुझे यहाँ पे unknowns find करने होंगे, first of all I will look here what are the number of unknowns that I need to find. Unknowns वो होते हैं basically जो हमें known नहीं होते, है ना. Okay, alright. So here यहाँ पे if I will just do one thing here, so now the rest of story is basically here. I want to know the number of unknowns here. Number of unknowns कौन सा यहाँ पे हो सकता है? Look, theta is given, it's not an unknown. Okay, normal reaction is not given here, it's an unknown. The first unknown I have here, that's a normal reaction. Okay, now the second unknown is here. The surface here is rough. जो हम रफ सरफेस की बात करते हैं, and there is a relative motion with block and the surface, and I expect that there must be the frictional force, है ना. The force of friction that will also lie here along this way. I am just going to represent this force of friction by this small f letter. Okay, and this is another unknown for me that I want to know. Okay, and there is a tension in the string that's not also given. Okay, and this is one more unknown for me, and there is a one more unknown here. This system, it will not exactly move with an acceleration due to gravity because there is a friction. It will just take apart, and as a result we don't have an acceleration of this system. Okay, under this gravity field it will move with a different acceleration. It's a kind of unknown. I can't guess it how exactly its value will be. Okay, now I have the 4 number of unknowns here. Okay, if I have the 4 number of unknowns, I must have equivalent 4 number of equations. Okay, so if I don't have the number of equations that is equivalent to the number of unknowns, it will be the bad thing for us. So we need to search and we need to use the laws of motion in that way, and so we should get exactly the number of equations that must be equivalent to the number of unknowns. Okay, now अगर मैं यहाँ पे laws of motion apply करूँगा, there are no issues. I can apply the laws of motion through any possible direction. आप मुझे क्वेश्चन बोलोगे, सर ये क्यों होता है? There is a simplest reason for it. Reason क्या है? Basically when we talk about the laws of motion purely, they are just working with the forces, है ना. Laws of motion deal करते हैं forces के साथ. Forces, you know, vectors, and vector can have any possible direction. Okay, vector may be oriented any other possible direction. There are no issues. So same is the case with here. I have one force here, normal force. It's a type of force, although it's a contact force, and I have the component of weight, and it is again the force. I have the, I mean, forces are going to be act this way around and this way around, this way around and this way around. I can apply the laws of motion through any of the direction. The reason is basically, when we talk about the laws of motion, they are working with what I can say the forces, okay? And forces, you know, they are vectors, and I give them an explanation why we can use the laws of motion through any possible direction. There are no restrictions, okay, and there are no issues. Now, in first way, how I can use my laws of motion here, if I will use the laws of motion in this direction, what will happen here? I will expect that the tension that will act in the string, okay, and if I will assume that this massive block M2, it is going to move downwards. जब ये move कर रहा है downwards, इसका मतलब क्या है यहाँ पे? इसका मतलब ये निकला, this block, इसका mass M1 है, ये करेगा move along this way around, okay? It means, and simply for me, there is no motion along this way around, है ना? तो यहाँ से कोई motion नहीं आ रहा है. Means that when there is no motion along this way around, forces they should cancel out in pairs, okay? तो अगर मैं laws of motion इस direction में apply करूंगा in a more general way, what I will get simply summation F, that will be MA along this direction, okay? Now, what's the first force that's going to be, I mean, lie along this direction? I can just say here, choice is yours. You can take this force or this force, okay? But I can assume here like my acceleration of a block along this way around is 0, because my block is going to move along this way, okay? It's because this massive block, it moves downwards. There is a tension in the string. इस tension से क्या होगा इस block पे? ये इसको move कराएगा along this direction against the frictional force, okay? Alright, so the first force I'm just talking about here along this way around, it will be the normal reaction minus plus, but this force is along this direction, it will be minus mg cos of theta, it will be 0, okay? Now, if I will just simplify it further, I will get simply here my n, it is equal to m1g cos of theta. This was the first unknown for me, and I got its value, okay? Now, when we talk about the second unknown here, it's a frictional force. You know the frictional force is defined as F is equal to mu times N, okay? Although it's an approximation, but this approximation holds well under the number of cases and all that, okay? So ये frictional force इसका value क्या आएगा? Normal force मेरे पास है, अब मैं यहाँ से frictional force को calculate कर सकता हूं, that's mu times, okay, the mu we are talking about here, it will be definitely the coefficient of kinetic friction, okay, because there exists a relative motion between this block and the rough surface, okay? So my n is here, it will be simply mu mg cos of theta, okay? Now for me, this is a frictional force. Now I got here the two unknowns, normal force and frictional force. It's a moment to calculate what's the tension in this system, okay? Now how I can calculate it? For that I need to use again the laws of motion. Just wait for a moment. It's a moment to calculate here what I can say the tension in the string, okay? Now for that moment I can calculate here tension. How exactly I can calculate? Again I will use the laws of motion. I told you as before, we can use the laws of motion in any of the possible direction. Reason you know why, okay? Now tension यहाँ पे calculate करने के लिए हम क्या करेंगे? Look, जो ये massive block M1 है, ये move कर रहा है along this way around. इसका मतलब जो tension है, it is going to be more dominate over the rest of forces here. I can again write my summation F, okay? It will be, now for this massive block I can write its mass, and if I will assume here the acceleration of this whole system, it is going to move with an a, okay, because it's an example of the connected motion. Whatever an acceleration of this system this massive block will have, it will be same for this one also, okay, because whole system is connected by means of the string has a massless property here, and we expect that the tension will be everywhere same. Okay, now how we can just calculate it here? It will be T plus, here is a one force, that's a frictional force, means it will be minus F, and there is a component of weight, that's L1 G sine of theta, it will be M1A. Okay, the value of frictional force, you know, as before you got the value of frictional force, it was mu mg cos of theta. Okay, I can put its value here. What I will get if I will transform this whole much here, I will get simply M1A plus mu M1g cos of theta, okay, plus M1g sine of theta. This is an equation that I have in hand right now. I need to calculate here T, but there is a one more unknown here, that's an acceleration. Okay, how I can calculate the value of acceleration here? That will be my point of interest here. Okay, now if I will just rub it here for a moment, if I will just number this equation first. Okay, now so far we got an equations. The first equation I got here, that was mg cos of theta, I can number it first, and the second equation I got here, that was frictional force, that's mu mg m1g, okay, cos of theta. Now I can number it second. Now I have the third equation here. That's m1a plus mu m1g cos of theta plus m1g sine of theta. Okay, now I can number this equation as third. Now I have one more equation here. If I will again apply the laws of motion, अगर इस ब्लॉक को मैं laws of motion apply करूंगा, generally Newton second law में यहाँ पे इसको apply करूंगा, this is going to move downward. इसका मतलब है weight of this block having mass m2 ये dominate हो रहा है किससे? Tension से. The first force I will just taking in consideration here, that's the weight of this block. Okay, means that m2g minus tension is same, it will be as m2a. Okay, I will use here a again because whole system will move with same acceleration. Okay, now this will be my equation 4. I got here the 4 equations, 4 unknowns. It's a good news, but for that I just calculate 2 unknowns. These are the 2 pending unknowns. One is a tension, another is an acceleration. Okay, for that I need to solve these 2 equations by using the rest of 2 equations. I will get here everything. Now I don't need to require the figure right now because I got everything whatever I need to require here. Okay, तो यहाँ पे मेरे पास कुछ equations आ रही है, तो I got the two unknowns here. Okay, now I need to find that another 2 unknowns by using these equations. Okay, algebra is some here hectic, but it is very simple. Now I can do here one thing. I can just transform this tension here and I can put it here. What I will get, मैं equation 4 को थोड़ा सा rearrange करूंगा. अगर मेरे पास यहाँ पे tension है, okay, it will be m2g minus m2a, है ना? तो मैं इस टेंशन को यहाँ पे करूंगा, इसको इसके साथ कंपीट करूंगा, तो मेरे पास क्या आएगा यहाँ पे? देखिए, I don't want to do here the number of steps. I will just skip the steps here so that my calculation will look bit easier. Okay, तो यहाँ पे मेरे पास m2g है minus m2a है, तो मैं यहाँ पे क्या करूंगा? अगर मैं इसके साथ इसको कंपेयर करूंगा, यहाँ पे है m1a. okay, तो मैं एक काम करूंगा, I can write it this way around. तो मेरे पास क्या आएगा यहाँ पे? Yes, it will be simply here. Now I'm just talking about the equation 3rd and the rearranging equation 4th. I will just compare those 2 equations. First, I will just make the comparison here. I will get here m2g. Okay, it will be here m2a plus m1a plus here is mu m1g cos theta plus m1g sin theta. Okay, this is my equation in hand right now. I can do here one thing, a is here, I can put it constant, and I can do one thing, I can put this all such here. What I am getting here is g, here is g, here is g, it is everywhere constant. I can write it as g into m2 minus, yes, here is m1 cos theta, mu m1 cos theta, okay, minus m1 sin theta. Okay, I'm just talking about the equation, last equation I have in hand. It's of this type, but the right hand side here I have here, it will be, yes, m2 is, m1 is here, so it will be here divided by m1 plus m2, and this will be my a. Okay, this will be my value of a here. This will, hope you got it, what are the symbols, what they represent here. Now I got the value of third unknown here, that's an acceleration. Okay, this is my third unknown here, this is my third unknown here. I can write it somewhere. Now the acceleration I have here, it is g m2 minus mu m1 cos theta minus m1 sin theta upon m1 plus m2. This is my the third unknown here, that was an acceleration. Okay, now I need to calculate here the fourth unknown. Okay, what will be the value of fourth unknown? Yes, so to calculate here fourth unknown, I need to use, I just need to make the use of equations here once more, but I will just try to give the equation that I have already with, that was, I will use the fourth equation here once more. What was that? That was m2g minus t2, it was simply m2a. Now what's the value of a here? It will be m2g here. Okay, now it will be here m2 minus mu m1, okay, cos theta minus m1 sin theta upon m1 plus m2. Okay, now if I will put my tension here, this here, what I will get simply my tension, it will be equal to, yes, here is m2g, here is m2g, I can just make it common here. Here it will be simply 1 minus this much. Okay, now if I will put it here, it will be m1 plus m2, but minus m2, and here it is minus, it will be plus and plus. Now m2 will cancel with m2, I will simply left with m1. Okay, but this m1 is here, m1 is here, m1 is here, I can just make it common. Okay, I can just make it common here, m1, and it is m2 here. Okay, now I am lefting with here what, m2 goes with m2 here, it will be simply 1 plus mu cos theta plus sin theta upon m1 plus m2. Now this is a this is a fourth unknown for me here. Okay, अब मेरे पास 4 unknowns आ गए. Okay, now by this way मेरी problem यहाँ पे end हो रही है. Okay, it was a question that was asks me what will be the value of normal reaction, frictional force, acceleration, tension. These are the values which are in front of you, and you know how we do this all such. ये application थी basically Newton's laws की. Okay, अब हम एक और प्रॉब्लम यहां पे डिस्कस करेंगे. एक और प्रॉब्लम हम यहां पे अब डिस्कस करेंगे. Let me discuss here the one more problem of this type. You know, when we talk about the general classical mechanics problems, हमारे पास एक such problems are basically fall into 2 classes. मेरे पास दो सिस्टम ऑफ क्लास प्रॉब्लम्स आ रही है. In one type of problem, basically the configuration of masses is given, and I supposed to be calculate the force. Okay. तो जब हम दूसरी क्लास ऑफ प्रॉब्लम्स की बात करते हैं, बेसिकली वहां पे फोर्स गिवन होता है, एंड वी आर सपोज टू कैलकुलेट द अनदर पैरामीटर्स. ओके, जस्ट लाइक एक्सेलरेशन, डिस्प्लेसमेंट, ओके, वेलोसिटी एंड सो ऑन एंड सो फोर्थ. तो यहां पे इस कैटेगरी की मैं बात कर रहा हूं यहां पे, of which the problem we have discussed as before. Now I'm just going to discuss one more problem of and this class, जहां पे अगेन कॉन्फ़िगरेशन ऑफ मास इज गिवन होगी, तो मुझे क्या कैलकुलेट करना होगा, बेसिकली द फोर्स. ओके, या हम कहेंगे एक्सेलरेशन भी कैलकुलेट कर सकते हैं यहां पे. तो अगर मेरे पास व्हाट आई कैन से, सपोज दिस इज जस्ट सीलिंग हियर. ओके, मेरे पास एक सीलिंग है, it will act as a kind of support. For example, string यहां पे है, it's of this type. okay, अगर मेरे पास एक सीलिंग है तो यहां पे एक स्ट्रिंग लगी हुई है ऑफ, तो but there is a pulley here, but pulley I'm just talking about here, it's massless, and there is one more pulley here. okay, but this pulley, although it's hanging over by means of the string, but it is movable pulley here. okay, if I will assume here the pulley I am talking about here, it has a mass m2, and the string, there is a one more mass here of this, and that's of m1. okay, if I will assume here this mass m1, it just moves downwards. okay, what will happen to this pulley here? Although it's a massless moving pulley, okay, it will move definitely with a different acceleration, because this pulley is not fixed with the string. okay, so it will move definitely with a different acceleration. But what I will expect, मैं यहां पे क्या एक्सपेक्ट करूंगा, मैं सिंपली ये एक्सपेक्ट करूंगा यहां पे, जब हम इस पुल्ली की बात करते हैं, although it's hanging by means of this string, but it is movable pulley. okay, now जब ये मास m1 मूव करेगा downwards under the gravity. okay, now if I will just assume that this is my here vertical y axis. okay, it's a general type of the problem. okay, तो यहां पे क्या होगा, ये पुली जो है, it's a movable pulley and it will shift. suppose this is a new position of this pulley. okay, अगर ये new position है इस movable pulley की, okay, we are going to have the string for this pulley, and it is going to be having the mass m2. now I am assuming here this mass m1, it is going to move downwards under the gravity effect. okay, what will happen here, again the tension that will act here, it will be everywhere same. Because of the same logics, because of the same reasoning. okay, now the tension will be everywhere same here, but for this block, what will happen here, for this pulley, it will have the tension along this way, and it will have the tension along this way. Again, as a consequence of the Newton's third law, tension at a body, it will be always away from it. okay, now when we talk about this block, it has a mass m1, it is going to move downwards under gravity. तो ये मास मूव कर रहा है downwards under the gravity field. तो यहां पे हम क्या एक्सपेक्ट करने वाले हैं, let we see. Look, अगर मैं यहां पे एज्यूम करके चलूंगा, जब हम इस m1 मास की बात करते हैं, ये मूव करता है डाउनवर्ड्स, क्या करता है डाउनवर्ड्स. लेट अस एज्यूम दैट जो हम m1 मास की बात करते हैं, एज इट्स गोइंग टू मूव डाउनवर्ड्स अंडर द ग्रेविटी फील्ड. ओके, एंड एज अ रिजल्ट द टेंशन विल डेवलप हियर. ओके, नाउ अगर मैं यहां पे एज्यूम कर रहा हूं, इट इज गोइंग टू मूव डाउनवर्ड्स विद एन वर्टिकल डिस्प्लेसमेंट ऑफ y1. ओके, and what will happen to this pulley, it will move upwards from this way around. There is a kind of symmetry from either side here. Okay, and it is going to move upwards here, it will move upwards here from this way. Let us assume that it will move y2, and this way around it will also move y2 upwards. Okay, when the net displacement was 0, what is going to happen here, when this block of mass m1, it is going to move downwards. Here is the massless pulley, but it is attached with some mass by means of the string here. What will happen to it, it will move up upwards. Okay, now the displacement from here, it should be equal and opposite the sum of displacements from here. Okay, this is something that you need to understand very bravely. It is as simple as but here what I need to do here, simply just look at, ध्यान दीजिएगा यहाँ पे मैं क्या करने वाला हूँ. If this is y1 here, it is going to move downwards, लेकिन at the same time इस massless pulley को क्या होगा यहाँ पे, although two pulleys we are talking about here, both are massless in nature, and this pulley it will move upwards. Okay, by the displacement here, if this is y2, this will be y2. I have the 2 times of y2. Okay, now this is an equation first. That I will be working with here, and I need this equation here, and this is known as the constraint relation. This is known as the constraint equation. It's an additional equation, we can say, in addition to laws of motion. Okay, in addition to the equations of motion, we have one more equation that's known as the constraint equation. तो ये मुझे बहुत हेल्प देगा इस प्रॉब्लम को सॉल्व करने में. हाउ, लेट वी सी, अगर ये massless pulley मूव कर रही है अपवर्ड्स, ओके, with some displacement at the same time, तो ये भी मूव करेगी डाउनवर्ड्स. दिस इज समथिंग वी हैव डिस्कस सो फार. अब देखूंगा मैं यहाँ पे कितने अननोन्स बनते हैं हमारे लिए. देखो, द टेंशन, इट्स अ फर्स्ट अननोन हियर. Tension is one of the unknown here. Okay, now as I told you before, this, although this massless pulley, it is hanging by means of the string, but it is movable. When it is movable, I will expect that it will move with a different acceleration. Okay, if I will assume here the acceleration of this massive block, it is going to move downwards with an acceleration of a1 for this block which is connected to this massless pulley moves upwards. It's a movable pulley. I expect that it will move the different acceleration. It will definitely move the different acceleration, and I assume that it will move the acceleration of a2. Okay, now I have the 3 unknowns here. I need the corresponding 3 equations. Okay, for that I have one equation in hand, but I need 2 additional equations. That equations I will get from the laws of motion. Okay, अगर मैं यहाँ पे laws of motion की बात करूंगा तो क्या आएगा यहाँ पे? See, if I will just look the problem this way around, this massive block moves downwards. I have the first force here, that's the weight of this block minus t. It is going to move with L1 A1. Okay, यहाँ पे आप ध्यान दीजिएगा, because जब हम इस ब्लॉक की बात करते हैं ये मूव करेगा with acceleration a1. Now I have this is my first equation, and this is my second equation, and I will have the third equation here. तो मेरे पास थर्ड इक्वेशन क्या आएगी, यहां पे ध्यान दीजिएगा आप. तो यहां से टेंशन एक्ट हो रहा है T, तो यहां से भी टेंशन एक्ट हो रहा है T. ओके, मीन्स दैट आई हैव 2T हियर, एंड दिस ब्लॉक हैज अ मास ऑफ M2G. ओके, इट विल बी M2A2. नाउ आई हैव 3 इक्वेशंस इन हैंड. Equation number first, equation number second, equation number third. The equation second and third, I got it after using the laws of motion. Okay, because this problem is again based on the laws of motion. I have the last 2 equations which I got from after using the laws of motion. But the first equation I got, it's an additional equation, and we call it there, it's a constraint equation. Okay, अब मैं इन्हीं 3 equations को यहाँ पे use करूँगा, and I will get these number of unknowns in the same way as before. देखो, अगर मैं equation first को यहाँ से फिर लूँगा, it's a displacement. Okay, अगर मैं इसको differentiation, if I will differentiate equation first, let me erase it for a moment. Let me rub it. I don't have the requirement of the figure right now, because I got everything what I needed to find. Okay, I need to find the tension in the system. Okay, acceleration is A1, A2, and the tension. These are the 3 unknowns. Okay, whose values I don't know, but after using these equations, it's not a big deal to find the answer of this question. Okay, now here मैं यहाँ पे क्या करूँगा, मैं अब इस equation को ले रहा हूँ. ओके यहां पे मुझे दो डिस्प्लेसमेंट्स आपस में रिलेट हो रहे हैं, तो मैं इसी को फर्स्ट डिफरेंशिएशन जब करूंगा आई विल गेट द वेलोसिटीज, जब मैं उसी इक्वेशन को सेकंड डिफरेंशिएशन करूंगा आई विल गेट द एक्सेलरेशंस, दैट्स व्हाट आई रिक्वायर। ओके तो यहां पे अगर मैं इस इक्वेशन को लूंगा, डिफरेंशिएट में करूंगा, इट डिफरेंशिएट इक्वेशन फर्स्ट विद रेस्पेक्ट टू टी। ओके मैं टाइम के साथ इसको डिफरेंशिएट कर रहा हूं, व्हाट आई विल गेट हियर, यस डी अपॉन डी टी ऑफ y1 it's equal to minus 2 is constant, it will be d upon dt of y2। okay तो इसको डिफरेंशिएशन करके I will get a v1, that's a velocity of first block and this is a velocity of second block। अगर मैं इस इक्वेशन को फिर से डिफरेंशिएशन करूंगा in a same way I will get here a1 is equal to minus 2 times a2। तो यहां से मुझे पता चला What's the relation between the acceleration of two blocks, है ना। तो मैं इस इक्वेशन को इसको मैं यूज कर सकता हूं and I will get everything। okay now now so far I got here my a1 is 2 times a2। okay now I am going to make the use of these two equations। तो मैं यहां पे क्या करूंगा, बेसिकली यहां पे मैं क्या करूंगा, मेरा जो a1 है that's 2 times minus 2 times a2। okay अगर मैं इक्वेशन फर्स्ट सेकंड को मल्टीप्लाई करूंगा थ्रू आउट बाई t by 2। okay here is 2, here is 2। now I am going to subtract these two, or I am going to simply add these two equations। जब मैं इन दो equations को यहां पे ऐड करूंगा for a moment मेरे लिए टेंशन क्या होगा, वैनिश होगा। now I will got here 2m1g is equal to m1a। okay now it will be this plus minus m2g here plus it will be m2 here it was a2। okay now I will use an above equation here, so if I can write it 2 m1 minus m2 into g, it will be yes 2 m1 here it is a1, my a1 is 2 times a2। okay so it will be minus 2a2 plus m2a2। okay तो इस हिसाब से मुझे a2 का वैल्यू पता चलेगा। okay all right so I will get the value of a2 here। what will be the value of a2 here, very simple, I am getting here the value of a2, that will be yes it will be 2 times m1 minus m2। okay divided by it will be yes m2, it will be minus 4 times m1। okay times g, this will be the value of a2 here। moment you are getting the value of a2 you can make minus 2 here, you will get the value of a1। okay it's a kind of homework for you people, like you are getting the value of a2 at the same time you will get the value of a1 by putting this minus half factor here, divide whole this equation by minus 1 by 2, you will get the value of a1 there। okay what will be that value, that will be not very far from this। okay because it's a constant minus half factor, we are just dividing it by, and we will get again here the value of a1। moment you are getting the value of a1 you can remind the equation that we have wrote down as before, that it was m1g minus t, that was m1 a1। okay from here you can calculate the value of t as well। okay it was m1g minus m1 a1। okay you will get the value of a1 at the same time you have put it here, and you will get the value of tension as well। okay this is not a big deal here, it's a simple right now an algebraic case here, you can just do and play with this kind of algebra, it's a good exercise। okay now Please, you must do it at your own places and you will get everything. This were the, the types of problems which are, how we discuss them in a general way by using the laws of motion. Okay, I think I must be stopped right now here. Thank you.